Hello and welcome back. In this episode we're going to take our Identity Server application and we're going to containerize that application using Docker, and we're then going to run the application using Docker Compose. So what we can see here over on the left hand side is our Identity Server solution with a single Identity Server project inside. You'll notice it's set up to use Entity Framework, so we have a data folder with migrations for both of the two database contexts. You'll notice that we have a startup class which registers Identity Server with the configuration store and operational store, and it uses a Postgres database with a default connection string, and sets up Identity Server to use, as I say, Entity Framework to store its configuration data and operational data. Inside the program class, we have a using block here, which migrates the database to be up to date with the persisted grant DB context. And we then have a using block here, which migrates the database to be up to date with the configuration DB context. And it then adds a new console client application into the clients table if the clients table is empty. So that's a brief whistle-stop tour of our new, essentially just empty Identity Server project with Entity Framework support. Next up, we're going to take a look at the Docker file and the Docker ignore. So starting with the Docker ignore file, you might be familiar if you've used Git with the concept of a git ignore file, and that essentially lists all of the files to exclude from the Git repository. A Docker ignore file is the exact same concept, however it's for Docker images rather than Git repositories. So if you have any files that you don't want to include in the Docker image that gets built, then simply add those files or folders into this Docker ignore file. So as you can see here, we have things like the license file, readme. You might have other, maybe secret files, encrypted, etc., that you don't want to store inside the Docker image. Simply specify any of those files that you want to leave out of the image inside this Docker ignore file, and it works in exactly the same way as the git ignore file does for Git repositories. So moving on, we'll take a look at the main Docker file itself. And you can see here we have a number of different stages. In this Docker file we have 4 stages, 1, 2, 3, and 4. There's our 4 essentially build stages inside the Docker file, and we're going to start off looking at this second stage just here. So you can see we say from the Microsoft container registry, pulling in .NET SDK version 5. If you're using a different version of .NET, then you can update that version 5 to whichever version you might be using, 3.1, 6, etc., whatever it may be. And we're labeling this image as build, and we get onto that in just a moment as to why that's important. So what we're doing is we're pulling down this image, the .NET SDK image, in our Docker file, and we're then specifying a work directory of /source. So this is going to run all subsequent commands from this source folder. It's the equivalent to opening up a command prompt in Windows, using cd to cd into a particular folder, and then running a whole bunch of commands after that sort of cd. That's what this equivalent is, this sort of work directory. You can see then we're copying the csproj file from our local machine on the left into the Docker image on the right. It's always essentially local machine on the left, local file system on the left, and the Docker image file system on the right. We're then running a .NET restore using that IdentityServer.csproj, and it goes without saying things like this run command, work directory command, those are executed from within the Docker image essentially. So this isn't doing a .NET restore on our local machine, it's doing a .NET restore inside the Docker image. So what this is going to do is going to, as I say, do a .NET restore to pull in all of the dependencies for the Identity Server project file, any other sort of things that are done during that .NET restore. It's then going to copy all files from our current directory in the local file system to the current directory or the work directory of the Docker file system. So what this is going to do, it's going to, as I say, copy all of the files within this Identity Server project from our local file system into the Docker image, excluding any files that we specified in the Docker ignore. So this is where the Docker ignore comes in handy, is we can specify we'll copy everything, but actually just ignore anything that's registered in the Docker ignore file. Much the same as if you do a git add all in the sort of root of your Git repository, it will ignore anything in the git ignore file. Docker ignore working exactly the same as that git ignore file. Once we've then done that copy command, we then do a .NET build for that IdentityServer.cs proj file with a release configuration, and we specify the output in the Docker images file system of /app/build at the essentially the root of the file system. So that will build the Identity Server project file, and it will output all of the build artifacts into that /app/build folder. Now you might be sat there wondering, why are we doing .NET restore and then copying everything and then doing a .NET build? Why don't we just copy everything, do .NET restore and then .NET build? And that's because Docker is quite clever in that it caches each one of these lines as a layer when it's building the image. So what it will do is it will pull in the Microsoft.NET SDK image, and it will then specify work directory of source folder, and it will then cache this layer of the sort of image, and it will then execute the sort of copy command, and it will then cache that layer, and so on and so forth, all the way down through the sort of Docker file. And what that means is when we're making changes to our source code in our project, obviously it's going to be continuously updating with changes to files, new files, etc. But if we don't touch the IdentityServer.cs proj file itself, so if we don't add any sort of NuGet dependencies, for example, if we leave that file untouched, then when Docker is building this Docker file, it will come into here and say, okay, well I've already pulled down the Microsoft.NET SDK v5, so that's done. I've already specified a work directory of source, so that's already done. I can pull that from the cache. I've already copied this identical file, so that's already done. And the bit where it gets really clever is I've already done a .NET restore for that file, so I'm going to use this cache layer here. But when I'm copying everything in, some of the source files have changed. Maybe the startup files changed. You've added a migration to the data folder. So I'm going to basically get to this point here, pull this layer of the image from the cache, and then carry on running these two sort of steps as I would normally. And that means it will only ever run the .NET restore once until you then add another dependency into that CS proj file, which speeds up build times to no end when you have a more complex solution with multiple project files. Essentially, what you want to do is specify your work directory, copy in all of your CS proj files that you use across your entire solution, then do a .NET restore of either a single CS proj file or just .NET restore the entire solution. And after that, you then copy in all of the rest of the source files into the image, and that means that, as I say, it will only do a .NET restore to pull in all the NuGet packages once, and then every subsequent Docker build, it will just come all the way down to this copy step and just resume from this copy step, taking everything above it from just the cache, which massively speeds up build times, especially when you're developing locally. If you're making rapid changes that you want to see as quickly as possible to preview them, having the .NET restore cached really does speed up the build times to no end, essentially. So this is doing the sort of build step, doing the restore and build, and you'll notice that we labeled that image as build. So once it's done this final step, it says, okay, here you go, here is your complete image, and I've labeled it as build. You'll notice in the next stage of the Docker file, we're then saying from build as publish. So whereas up here, we're saying from the Microsoft container registry, pull down .NET SDK. So go off and fetch that over the network from the Microsoft container registry. By specifying from build, it's saying, okay, don't go off anywhere to pull the image from some remote container registry. just use the image that I've labeled as build, which of course is this image just here. So it's using that image as the sort of base for this stage, and it's labeling it as publish, and then it's running .NET publish IdentityServer CS proj with that release configuration, and it's outputting the published DLL file to /app/publish. So we have our build step here, and then we have our publish step as two distinct images, like so. And you'll then notice that we have our final step down here, which says from base as final. So this from base, you'll notice that we have an image up here at the top labeled as base. And this is going to the Microsoft Container Registry, pulling in .NET ASP.NET version 5, specifying a work directory of just /app, exposing port 80 and port 443, because this is going to be a web app, so it's going to need those web ports, HTTP ports exposed. And so it's saying, go off and, use this image from our sort of local, Docker sort of cache, rather than going off to any sort of remote container registry. Set the work directory to /app, and then we're doing a copy command to copy the DLL from our build step into this sort of final base image. So this -- from equals publish tells the copy command to look in the publish image rather than our local file system. You'll recall these two copy commands up here by default copied IdentityServer CS proj and then all files from our local file system over here into the Docker image, whereas this copy -- from equals publish tells it don't look in our file system for those files, look in the publish image for those files. So it's then going to copy from this publish image /app/publish. Everything in that publish folder is going to put into the current directory of the Docker image, which is this work directory of /app. So it's basically going to look in the publish image inside the app/publish folder, which you'll recall is where we published our IdentityServer.dll output to. So it's going to pull in that DLL, copy it into that app work directory, along with all of the other sort of DLLs that are sort of output in that publish step. Copy all of those into just our /app folder at the root level of this image. And then last but not least, it specifies an entry point of .NET and then IdentityServer.dll. So that's running the .NET command, and it's essentially running our IdentityServer.dll, which is our Identity Server application. So essentially, as I say, this is a 4-step process building 4 separate images, each with their own label. And you're probably wondering to yourself, well, we're pulling down this SDK image here as this second stage. Why don't we just, after we've done a build, do a .NET publish, specify the work directory to wherever we publish that output to, and then simply just run the entry point of .NET IdentityServer.dll from our SDK image, all as just one single image, because we still have layer caching, even if we just used one image. The reason that we use multiple images is because we have this SDK image and this ASP.NET image. And as you can imagine, the ASP.NET runtime image is much smaller and lighter weight than the full-blown SDK image. The SDK image comes with all of your, your .NET Restore, .NET Build, .NET Publish, all of your global .NET tools, etc. So that SDK image is a much larger image than the ASP.NET runtime image. So we use the SDK image to do all of our restoring, building, publishing, and then once we have our DLL files published, ready to go, we drop back to the much lighter ASP.NET runtime image, which just comes with the ASP.NET runtime and none of the .NET SDK or global tools, and we then use that much smaller ASP.NET image as our final image to run the application in. And that means that the final built image as a result of this Docker file is much smaller than if we use the SDK. And so that means that when you're uploading that image to container registries, takes up much less space, it's quicker to start up, and various other sort of benefits. So that's why we have these sort of stages as multiple distinct stages in separate images, rather than just using a single large image based on the .NET SDK. Restoring, building and publishing using the SDK, and then the actual running of the final DLL using the much smaller ASP.NET Runtime image. So that's an overview essentially of the sort of multi-stage Dockerfile setup to build ASP.NET Core web applications. Again, I'm using IdentityServer for this example, but you could be using any ASP.NET Core web application. It could be a Razor Pages app, an MVC app, could be a web API project. Just got to make sure, of course, that you adjust the names of the CS proj files appropriately, and also then of the final DLL to make sure it matches the name of your projects, whatever you've called them. So that's a look there at the Docker file, and what we're going to do now is take a look at our Docker Compose file. The Docker file is used to essentially build that image, and then Docker Compose is used to essentially orchestrate all of those images and run them together. So this is our Docker Compose file at the time of recording, version 3.9, the latest version of Docker Compose. And you can see we have our services block and our volumes block. So we'll take a look at services first, and you'll notice, first and foremost, we have a DB service. So this DB service is essentially our database. The beauty of using Docker is that we could have a Postgres database, a SQL Server database, MySQL database, whatever it may be, running inside a Docker container, and we don't have to install that database server onto our local machines. It can be running in full isolation in a Docker container. We can spin it up and then we can shut it down, and there'll be no impact on our local machine. We won't have to install anything above and beyond Docker itself. So this database service, you can see we specify an environment variable of Postgres password equals password. Now this database is going to be using Postgres, it goes without saying. However, feel free to use SQL Server, MySQL, whatever it may be, just updating the image and the environment variables, port numbers, etc. appropriately, depending on your chosen database server of choice. So this environment, Postgres password, is the password that is used to connect to the database server. The image, as we can see here, is Postgres version 13. So this is going to pull down the latest version 13 Postgres image into our container and then spin that up as our database server. We specify ports 5432 on our local host and 5432 inside the Docker container. That means if we go to port 5432 on our local host, that will route down into port 5432 of this DB container. And last but not least, we then have this volumes. And this basically allows us to persist data between Docker Compose sessions. So when you run Docker Compose up, it spins up all of your containers with all of your images running. And then when you run Docker Compose down, it spins down all of those images and containers. And if we weren't persisting the database data between sessions, then you can imagine every time you run Docker Compose down, it would wipe all of the database's data, which isn't ideal, let's be honest, because it means you've then got to recreate the database every single time you spin up the database service here. So what we're doing is we're saying, okay, Docker, go off and create just a a named volume called DB. Go and manage that yourself internally inside the internals of Docker, and I want you to store the var lib PostgreSQL data directory inside that volume. So what will happen is you'll run this Docker Compose up for the first time, and it will create this Postgres container, and it will then mount this var lib PostgreSQL data folder into this DB named volume that Docker is managing for us internally. And when we then do Docker Compose down to spin down all of the containers, Docker will persist this data folder in this DB named volume, which means that if we say, tomorrow, rerun Docker Compose up, Docker will come in here, it will take the DB named volume, and it will copy the contents of that volume and mount that into the var lib PostgreSQL data folder, which means that the data is then persisted between Docker Compose sessions. So that's essentially, this volumes bit is what allows us to keep, all of the data in the database, between sessions, between running Docker Compose down and then running Docker Compose up again at a later date. Of course, if you delete that volume, it will then wipe all of the database data. But whilst that volume is still live and not deleted, it will essentially just keep mounting that into the container and updating that DB named volume when more data is added into that Postgres database whilst it's running. So that is how we can essentially, as I say, save the database's data between sessions. And this then volume down here at the bottom, this DB named volume matches the name given to the volume up here. So if you call that database rather than DB, then make sure in this volumes block at the bottom you call it database and not DB. You can also check out the Docker Compose documentation for other sort of options that you can provide to this DB named volume. There's a few options that you can provide down there, but we'll just leave that blank for now. As I say, feel free to take a deeper dive into the Docker Compose documentation to take a look at those options that you can provide to the named volume. So that's the DB sort of service explained, and we're now going to take a look at the IdentityServer service. So this IdentityServer service is what's actually going to be running our IdentityServer application. Again, if you're following along with your potentially other web app project, feel free to call this service whatever floats your boat really. You can see here it's building the IdentityServer folder. So what that build sort of option is doing is telling Docker to look inside the IdentityServer folder, and it's saying look in there for a Docker file, which is this Docker file just here, and it's then telling Docker to essentially build that Docker file and then run the image within this container. So you'll notice in DB we simply specified image Postgres, whereas in IdentityServer we're specifying build and then a local sort of path to the Docker file. And that's because the Postgres image is already built for us. It's up in the Docker container registry in Docker Hub, so we can simply pull down that already pre-built image, which is why we specify just image like so. However, our application is a custom Docker file, and so we're saying, hey, rather than going to this remote container registry and pulling down this pre-built image, we need to actually build the image as part of this Docker Compose file. Next up, we can see it depends on DB. So this is because the IdentityServer obviously needs the database to store its data in. So this depends on DB basically tells Docker Compose, hey, before you build this IdentityServer, make sure that this DB is up and running beforehand. So it basically makes sure that DB is spun up, it's running, ready to go, before then building and running the IdentityServer application. Next up, we have a whole bunch of environment variables. So you can see here we're specifying ASP.NET Core environment equals development, because we're just developing locally. If this was production, you can change that value from development to production, or you can just remove that entire environment variable entirely and it will default to production if it's not specified. We then say the ASP.NET Core URLs that it's running on. It's going to be HTTPS port 443 and HTTP port 80. These should match the ports that we've exposed inside the Docker file. So we can see here port 80 and port 443 are exposed from there like so. And that should match the ports that we then specify for the application to be running on. Otherwise you won't be able to send requests in and out of that container on those ports. We're then going to come back to the Kestrel certificate in just a few minutes time, so stay tuned for that. Last but not least, we have the connection strings, a default connection. You'll recall in our startup class, we use a Postgres database with configuration.getConnectionString default connection. That default connection matches this connection strings __ default connection block like so. Now you could of course specify the connection string in the app settings file, and you might be wondering, what on earth are these double underscores doing here? What does that mean? A double underscore is essentially sort of nesting one layer deep in the sort of JSON as an equivalent. So if we specify underneath this logging, if we said connection strings and then created a variable called default connection, like so, connection strings there matches connection strings there in uppercase, and you'll notice we then have a like nested object, and that nesting is what this double underscore provides for us. And we then have a property called default connection, and that default connection is then this default connection in sort of capitals here, like so. So that is what the double underscore represents in the .NET environment variables. So yeah, that connection string's default connection would be the equivalent to putting it here as a connection string default connection in the app settings.json. So then we specify that default connection string to be server equals DB, port equals 5432, database, identity server, user ID equals Postgres, and password equals password. So the password equals password matches the Postgres password that we defined in the Postgres container environment variables. If you change that password, then make sure you update it in the connection string, of course. And the port 5432, that's the default Postgres port, and we can see there we've exposed that port 5432 in the list of ports for the database container. And last but not least, the server is just DB. And you might be wondering, well, I'm used to a server either being maybe localhost if you're running the database server locally, or a URL to a database server running in the cloud, for example on Google Cloud Platform, Microsoft Azure, Amazon Web Services, etc. But we've just got server equals DB. And that's because the Docker Compose creates an internal network for us, essentially. And it can automatically map these DB names in shorthand to the DB container. So when we say server equals DB, Docker Compose in its internal networking setup will go, aha, right, server equals DB, I have a container called DB, and so I'm going to route request to that server into the DB container. Goes without saying, if you call the container something different, like database instead of DB, then make sure the server equals database instead of DB. Essentially, that value there and that value there should both match one another, and again in the depends on, that should match the server service name as well. So yeah, that server equals DB, basically Docker Compose internally for us in its networking setup will automatically route any sort of request to that DB server into the database container running our Postgres database. You can then see our ports. We specify port 5000 on our local host to port 80 inside the container. Again, we have HTTP running on port 80, and we exposed port 80 in the Docker file. We then have port 5001 on our local host, pointing to port 443 inside the container. And that's because HTTPS is set to run on port 443, and we exposed port 443 inside the Docker file. So again, those 2 ports on the left are the ports on the sort of local host on your local machine. So if you went to localhost port 5001 in the browser, for example, that would route the HTTP request into port 443 of this identity server container. Last but not least, we have our volumes, and this is similar to our database volume, but you'll notice on the left-hand side here, we are explicitly specifying a local directory on our local file system, rather than just a volume name like we've done up in our database volume. That's because we are mounting the ASP.NET app.pfx file from our local file system into the container at the root of the container, https ASP.NET app.pfx, and we're also specifying it to be read-only, so the container won't overwrite that file. It's just read-only. Now what this is doing, slightly different to the sort of Docker managed named volume, this is actually mounting, a file in our local file system into the container. If we wanted to store the database's data in our local file system between sessions, then we absolutely could do. You can simply replace this DB named volume with a path to anywhere on your local file system, get rid of the DB volume down here, and that would then mount all of the container's database data into that local file system path. And when you then spin up that database container at a later date, it would mount your local host, file system from your local machine into that database container. So this is looking for the ASP.NET App certificate. This is the HTTPS development certificate, which I will get onto in just a second, that .NET Core provides for us. And it's basically mounting that certificate into the container's file system at that path, and specifying it's just read only, so it can't be overridden by the container. And this is useful because you might be wondering, well, surely we could just add that file into the into the container's image. We have a Docker file here. We're copying files into the Docker file. Why don't we just copy that certificate into the Docker file? I mean, makes sense, right? It saves us having to have this, extra complexity of a volume mount from our file system into the container. But the downside of doing that is that you then embed that certificate in the Docker image. The beauty of having these Docker files like so is that you can run this exact same Docker file in production without a change to the actual Docker image itself. So with this sort of single configuration across all environments, you can spin up this Docker file using this Docker Compose locally, and you can set the environment to be development as an environment variable. You can mount, the self-signed HTTPS certificates into the container, set the default connection string to just, a local database or a database running inside the Docker Compose, and you can still be using that exact same Docker image as you would then deploy to production. But of course, in production, you'd have, different environment variables. You'd have, you'd have a database connection maybe in the cloud somewhere. It would be a production environment rather than development environment, but it would still be the exact same image. And the useful thing with that is it means that when you're developing locally, you can rest assured knowing that you are using the exact same Docker image that is then going to be pushed out and deployed to production that you're running locally. So that's why we have this certificate file mounted as a volume and not just added into the Docker file, because if we add it into the Docker file, then that self-signed HTTPS certificate is then embedded in the Docker image in production and in development. Whereas with this mount, it's just mounted into the container, and the Docker image itself is still clean and can be used for production, staging, however many environments you may or may not have. So that's the benefit, as I say, of using this volume mount rather than just copying that certificate directly into the Docker image. And what I'm going to get onto now is how to actually export that HTTPS development certificate and trust it on your local machine, and then mount that developer certificate into the container so it can be used as the SSL certificate, self-signed, to be used by the IdentityServer running in the Docker container. So what I'm going to do is I'm going to jump into a PowerShell window like so, and I'm going to type in .NET devcerts https -- help, and this will bring up all of the options that we have to handle the HTTPS development certificate. And as you can see, we have this export path option and we have a password option. So the export path is the full path to the exported certificate, and the password is the password to be used when exporting that certificate as a PFX. So what we're going to want to do is we're going to want to again do .NET devcerts https, and we're going to want to say export path, and I'm going to use env and then a user profile, which is essentially your local user folder in Windows. I'm going to say .ASP.NET, and then I'm going to say HTTPS, then ASP.NET app.pfx, like so. As you can see, that is then matching this sort of path that we've got defined in our local file system on the volume mount, .ASP.NET https ASP.NET-app.pfx, like so. And then I'm going to specify a password of password. And as you can see, back in this Docker Compose file, we specify on line 18, ASP.NET Core Kestrel Certificate's default password equals password. So what I'm going to do is I'm going to run that command like so. And if all goes well, we can see a valid HTTPS certificate is already present. And if we would now navigate to that folder, we should see an ASP.NET-app.pfx file. So in fact, let's do that. If I open up a new tab, and if I go cd env user profile and ASP.NET and then HTTPS, and if I then list what's in this directory, you can see that we have ASP.NET-app.pfx, like so. So that is our certificate exported to a PFX file. And what we can then do is we can trust that certificate on our local machine. Otherwise, we will get all sorts of errors in the browser saying that it doesn't trust the SSL certificate being used to encrypt the HTTPS connection. So what we can do is we can say .NET devcerts https --trust. And we can see we then have this security warning prompt saying that we're about to install a certificate from a certification authority claiming to represent localhost. And what this is going to do, it's going to install this root certificate into our trusted root certification authorities. And that is going to allow us to then navigate around sort of websites in the browser with the certificate being trusted, so we don't get any big sort of warnings in the browser saying, watch out, you know, this is a non-secure connection, essentially. So we can hit on yes to install that certificate, and once again, a valid HTTPS certificate is already present. So that command has worked for us. And so what we can now do is we can come back into here and we can double check again that ASP.NET HTTPS ASP.NET-app.pfx is mounted from our local file system, and it's mounted into the container file system at the root directory https ASP.NET-app.pfx, and we specify that container file path as the default path inside this ASP.NET Core Kestrel Certificate's default path environment variable. And we then specify that password to be password, which is the password that we use to export the certificate with. Again, it goes without saying, because this is a development certificate, I'm just using password. This certificate should not be used in sort of production or any other non-development environment. But feel free to use any other password that you like as the PFX password. So with that certificate exported and trusted on our local machine and set to be mounted into the Docker Compose file system, what we can now do is we can run our Docker Compose run configuration in order to spin up these services. So if we come to the top right there and hit the run button like so, we can see here that it's now spun up these containers, and if we expand that, we can see that we have a database container running and we have an IdentityServer container running. You can see the images it's pulled down. We have Postgres version 13, which matches the image here, Postgres 13. And we can see it's given the IdentityServer image a name of IdentityServer _ IdentityServer : latest. And that is what it's that's what it sort of default tagged the image of this just build command. If you wanted to give that image a different name, then feel free to use the sort of options available in the Docker Compose file to do that. But I'll just leave that as the default name that it gives it by itself. So with the database running and IdentityServer running in Docker containers, the first thing we can do inside our IDE is we can open up this database tab on the right, and we can add a connection to that Postgres database. So if we pop down to New, Data Source and Postgres SQL, we're connecting through a local host and we're using port 5432. If you recall, we exposed here port 5432 on our local host to port 5432 of the container. If you used a different localhost port, then you would use that different port number here in the database connection. Username and password. The default user for a Postgres database is simply Postgres, like so. And you'll recall that we set the password to just be password. So we give that a value of password. We just leave that as being saved forever because it's a local development database. We don't particularly need to worry about being prompted every time for the password. And if we get rid of this default database, and if we do control space to autocomplete, we have a Postgres database and an identity server database. So if we select that identity server database and test the connection, you can see here we have Postgres database version 13.3. That's the most recent version 13 at the time of recording. And we have succeeded to connect to that database. So what we can do is we can hit apply, hit OK, and we have our database console opened up here like so, and we have an identity server database. You can see within this identity server database we have our tables and we have all of our identity server tables. And if we open up the clients table, you can see here that we have a console client. You may recall in the program class way back at the beginning of this episode, we set up our console client to be added to the database if the clients table is empty, which at the first time of running the application it would be an empty table. So it seeds that clients table with a just dummy console client with a client secret of just secret. So with that client created in the database, like so, we can then open up the identity server in the browser and we should be able to see the well-known discovery document endpoint. So if we pop into Chrome and if we give this page a refresh, give it a few moments to load up in the background, and we should have, as you see here, our identity server discovery document. You can see running on localhost port 5001, well-known OpenID configuration. And that port 5001 correlates with the port 5001 that we exposed from our localhost into port 443 of the container. If we were to use port 5000 in the browser, then we would be running over HTTP down into port 80 of the Docker container. So essentially that has shown you how you can get just a brand new empty identity server using Entity Framework converted from running locally on your local machine into a full Docker Compose orchestration with a database container and an identity server container. As I said, I hope you found this episode very useful. Thank you very much for watching, and I'll see you next time.